you guys are viewing this tape right now, it means I'm probably off the island at this point, so I'm going to go ahead and go over the quiz from last time, quiz 4. Number 1 on the quiz, I'll read it. It says I roll some loaded, not fair dice 50 times and I get 12 nines. What is the 96% confidence interval for the proportion of nines that this pair of dice will roll? So it's not a pair of fair dice. It's a biased, they're loaded dice. So we're just doing a sample to see how many nines we get. And out of 50 rolls, we get 12 nines. So that's a sample, p hat, and we're getting 12 nines out of 50, which is 24% or 0.24. So that's for the sample. I need to construct a 96% confidence interval for the proportion of nines rolled by this set of dice. So 96% confidence, I'm going to need to use a confidence interval formula, which is going to be margin of error is equal to the z-score sub alpha over 2 times the square root of p hat, q hat divided by n. So I'm going to need a z-score chart for 96% confidence. 96% confidence means I'm going to have 2% area in each tail because 96% is in the middle. So I need to find a z-score. I'll look in the negative z-score chart for the z-score that's closest to 2% on the left-hand side. And if I look in the chart, I get 2 scores on the negative z-score chart. 2.02 is the closest, and that is negative 2.05. So that z-score is negative 2.05. Because of symmetry, we know that one's positive 2.05. It doesn't matter if it's the positive or the negative, remember, because you're going to use that score to get the margin of error, which you will then add and subtract from p hat. So that's the first number I need is this 2.05. Next thing I need is p hat, which I've got already, 0.24. I need q hat, and all you got to do to get q hat is subtract p hat from 1, so that's 0.76. And then divide that by the size of the sample we took. Well, we rolled the dice 50 times. So we put all of this mess into the margin of error formula for the confidence interval for proportion. Remember, this is out of chapter 7. And we get, after putting that into the calculator, 0.124. So that's my margin of error. All I have to do to come up with my confidence interval now is add and subtract that to p hat. So my confidence interval is going to be p hat plus and minus e, so it's 0.24 plus and minus 0.124, and what that gives me is this nice interval, 0.116 all the way up to 0.364. So there's the 96% confidence interval for the proportion of nines rolled by this set of loaded dice given this sample that we already took. So we already rolled it a bunch of times and got almost a quarter of those times were nines. So obviously the dice, something's kind of weird with the dice. And now I can be 96% confident that the proportion of nines rolled with that particular set of dice is between those two proportions right there. So that's number 1.